Hi, everybody, and welcome to the Future AI Show. My name is Matt Brown, and with me on the line is Dimitri Fisher, the Chief Scientific Officer at Dynam.ai, doing incredible things with context augmented AI. And today we're going to be getting into implementation, real world implementation of AI solutions. So, Dimitri, for our viewers around the world who potentially haven't heard of the incredible work that you've been doing in the field of data science and AI, why don't you give us a little bit about your background and fill our viewers in from around the world?
Sure. Thank you, Matt. Uh, so I'm physicist by training, physicist and computational neuroscientist. So I've been doing really machine learning for a really, really long time, but I sort of came into doing what's now officially called machine learning in a fairly roundabout way, but I've been doing it for quite a while, just from different angles. And one thing that's really important to realize, especially in the context of augmented machine learning, as Matt just mentioned, is that people have sort of tend to have a fairly exaggerated picture of the abilities of artificial intelligence in general and of machine learning algorithms in particular, think sort of anthropomorphizing them, thinking that they have access to the same common sense we do, and they don't. And that's kind of like the elephant in the room of the machine learning,
Hmm.
and that's what I'm trying to address, or addressing more accurately.
Yeah, and why do you think they have that prevailing perspective?
Oh, that's due to the cinema, the manga, the books. I mean, the robotics did not come from engineering. Robotics came from theater, right? The word robot, and the whole sort of the whole perspective on artificial intelligence, whether it's something really belligerent like a Terminator or something really calm and soothing like Yokohama Shopping Log. Either way, I mean, it's anthropomorphic, and it's really not, or at least not in the first and second generation of AI. Hopefully, it will be more peaceful and more anthropomorphic in the third wave of AI, but that's yet that wave is only just starting to build up. It's nowhere near cresting yet.
Hmm. So you've been working on some amazing projects, not only at Dynam, but also before Dynam too, DARPA being one of those. Can you describe a specific project or initiative that you have led at Dynam.ai involving the implementation of artificial intelligence in a real world setting?
Oh yeah, sure. So yeah, I mean starting way back. So before Dynam, it was AV Lab, and before I joined the AV Lab as the chief AI officer, I was at Brain Corporation. So back then, that was the when the second wave of artificial intelligence was really picking up speed, and so we had a number of projects, and one project that we did back then with BrainCorp was for DARPA. And that was a pilot project on basically cortical processing, how the cerebral cortex does what it does sort of computations, quote unquote. I mean, I'm not pretending to think our brain is a computer, but just hijacking the word computations. And one of the really important thing, and back then the feed forward deep architectures were all the rage, but one thing that was painfully apparent is that the feed forward architectures don't do uh, what nearly what what the human brain does, either both when they're learning and when they have learned. And it's well known now, but back then it was less apparent or less obvious. And one thing, the two related things that they're really missing are attention, and I'm talking about both bottom up and top down attention, and context. And that is, I mean, that project was finished successfully, and Brain Corporation went on to develop a self-driving, basically it's like a Zamboni. It's a big ride-on floor cleaning machine. You definitely don't want it touching anything or hitting anything, and it goes around and cleans things. And there's a lot of machine learning and AI that went into that under the hood. You don't see it necessarily. And BrainCorp is very successful. So I actually resigned from BrainCorp. That was 6 years ago, about 6 years ago, and joined what was just starting as Analytics Ventures AV Lab to pursue specifically things where the AI and machine learning can be applied to the real life. And there were a lot of different projects. Due to NDAs, I cannot go into some of them. I can go into others, but the key to still, I mean, the bottom line is the key to solving real world applications with machine learning with AI is the context, and that's where the focus of my work is at.
Great stuff. Thank you, Dimitri. So, could you just explain, give me the elevator pitch in our viewers around the world when you talk about context augmented AI? What is that exactly? Because there's a lot of talk right now. Everyone's talking about it. Chat GPT-3.
Oh,
You know, you and I and Diana and the rest of the team at Dynamo were also talking about this last week. So everyone's talking about Chat GPT-3. That's what people are most familiar with now when it comes to AI. And then you guys are specializing in context augmented AI. So what is context augmented AI, and
that
how is it different for our viewers who are thinking, oh, AI is like a chat function?
that's an excellent question. Yeah. So when context augmented AI, so the way obviously we were not involved in any way in development of Chat GPT. I mean, that goes without saying. I want to make sure I'm not taking any credit for something I was not involved in, and I was not involved in that at all. So that's not related to Dynamo. The context in our context, the context is the physics, or the laws of physics, the laws of society, the laws of nature, something that you can express or express mathematically or model. It's not context in a sense of language. It's a context in a sense of the real world, common sense, if you want, but really the real world, how the real world works. It's that context. Something we learn as toddlers. I mean, you give your kid a sippy cup, and then they figure out how sort of what spills and what not spills, or what falls and what doesn't fall, and then they go onto a plastic cup, and then they can handle a ceramic or a glass cup or whatever.
Fair enough. Well,
That's
thank you.
all.
Thank you for the explanation. So, Chat GPT-3, what are your initial thoughts on the technology?
My thoughts is, first of all, this is excellent. This is extremely exciting. And another thought is there seem to be two camps. One camp claiming that this is not really speech. This is sort of kind of like eliminated immortal parrot brain, that it just read everything there is to read on the internet, and now it's just spewing prepackaged pieces of internet derived text. And then the other camp is actually really excited about it, because it allows synthesis of new ideas by combining knowledge from disparate areas in which very few people actually are experts in. So it's very hard to find people who are experts in many disparate domains. Usually, one person is a narrow expert in one domain, and it's relatively few people who just by being very rigorously academically educated or very curious about a lot of things, or just having gone from one area of science to another to another to another, that they have these enough breadth of knowledge to see how things may combine, or how you may borrow from one area domain of knowledge to enhance another. So I still am undecided. If you want me to vote, like left or right, I'm undecided. I have no party allegiance. I'm the jury is still out there.
The jury is still out there, and I think the jury is going to be out there for some time to come. So anyone who's standing up going, "This is the way," I wouldn't suggest is a credible behavior at all. So Dimitri, I want to change gears with you for a moment. How do you ensure that the AI models developed at Dynam AI are reliable, accurate, and fair? For example.
Okay, that's really several questions folded into one. So without going into deep and blowing our time budget, so there's several things. There's first of all explainability, and it's when you're talking about complex networks, it's a posteriori explainability. So you see what features it learned, or what areas or what features uh, its decisions can be attributed to, and think so. That's one. The other one, and that's really unique to us, is because we use context augmentation. We know where a lot of knowledge is coming from, because we know the mathematical model that, or in general the model that sits behind the decision making. And I'm not going into specific architecture of how context augmented machine learning works, but for the broader audience, it allows to use the information that's not there in your original data set, uh, sort of to augment it, not in a sense of data augmentation, not to make more of the data, but to make the data richer. So to add information to the data that is not originally contained or not originally salient in it, so that your machine learning, your eventual solution, can account for the right things, and not overfit to or learn some artifactual or superstitious things that just happen to be there in your data set, either because of the sampling bias, or because of how the data set may have been annotated, or because of just data set not being big enough or not being comprehensive enough. So that's and then there are other we also have other IP, how to do stratification correctly in complex cases, and so yeah, we have a whole set of tools of how to make AI actually work in real life.
Dimitri, when it comes to the real world implementation challenge of a typical business, let's just say, if you think about a client that you might have in the manufacturing industry, or maybe someone in the agroforestry industry or the agriculture industry, when they're looking at drones and, trying to map geographical terrain, and there's so many applications for AR. But in your experience as chief scientific officer, what are some of the constant challenges that you find your clients experiencing on the ground when it comes to implementing AI in the real world?
That's an excellent question, Matt. That's really an excellent question. I would name several. First of all, it's the so let's go from the top level down. At the topmost level, you need to fully understand what is it that you want to do? Because you need to ask the what question before you ask the how question, really. And that's been sort of our um sort of the that I claim no credit over that. It's almost a platitude. That's what I want to say. So, but you really need to ask the what question before the how question.
Mm.
You need to fully understand what it is that you're trying to do, and when what data would be required, whether you have the required data or whether you're planning to generate the required data, and whether it would need to be annotated. And that then we're getting into the how question. But first of all, you need to fully understand the what question, what it is that you're endeavored to do. And then into the how is how you endeavor to do it, both on the data collection side and on the architecture side, on the implementation side. And then and all that has to be commensurate with the actual time and material and resources, and the because the data oftentimes is the bottleneck. I mean, I heard people say that 80% of data science is data janitorial services, and I agree with this completely. That's been my experience and our team's experience as well. Because some clients have absolutely immaculate data, but some clients don't. And even when the data is really good, the other really important question is whether it is sufficient. Now, when you use context augmentation, you can get away with less data. You can use less data because and certainly with less annotation. That's one of the benefits, because then you can use a computational model. Computational model doesn't require any annotation; it generates its own. So, and you can learn by prediction, just the future, predicting the future state of your system, of your model, given the current and past ones. That's so self-supervised. You don't need any annotation. It's just self-supervision. So there are ways to get around the data issues, and then there's traditional ways, obviously, which is the all the approaches with transfer learning, and all the approaches with boosting, bagging, all the bag of tricks, pun intended, with that's involved in making your data more plentiful, the semi-supervised approaches, all that. But and I'm not going into the detail, but I can if we have a longer.
Fair enough. Dimitri, one more question, then we'll wrap up this particular episode. What's your advice to a potential decision maker who's looking to implement AI? If I know it's a big question, but from your experience really implementing this stuff every day, what's your advice? In terms of like the implementation of artificial intelligence solutions, where, like if there was one thing you would hang your hat on, say, hey, start here, or here's what I've learned, or what is that?
Yeah, talk to the experts. That's one thing. Yeah, I mean, when companies and sometimes middle management in big companies, they think, oh, people are doing AI, we should do an AI, and then they hire people right out of the undergrad, like with a lot of learned knowledge, but without much of hands-on experience. And then a year later, they discover that no, we burnt a year and then $1 million.
Mm-hmm.
That doesn't work. Just talk to the experts. I mean, I'll plug shamelessly. Talk to us.
Yeah, it is the
Talk to any of the people who spent years doing this, because there's a lot of hands-on knowledge that you don't teach you the university.
yeah, it's a really great point to end on, because you just don't know what you don't know. And so many clients I know trying to implement AI in the real world, what happens is they, to your point, they spend $1 million on a project that doesn't go anywhere.
That's true.
Or they try and hire people internally, and then there's everything else that goes along with that. So to get time to value or to shorten your time to value, speak to an expert. So that's a really great advice. Dimitri Fisher, thanks for being on the Future AI Show. Thanks everybody for tuning in. We'll get Dimitri back. I feel like we've just scratched the surface, but I wanted to introduce him to all of you. Dimitri, thanks for being on the show.
Thank you, Matt. Really great questions too. Thank you.
Anytime. Cheers,